Hello, and welcome to this lesson of our C Programming Foundations tutorial series. I'm Reza, and I'm happy to have you join me on this journey to mastering the C programming language. So, let's talk about functions in C programming. They're really like the building blocks of a program. You've got two main types: the library functions, which are ready to use and come with the standard C libraries. And then there are user-defined functions, which are the ones you write yourself for specific tasks in your program. We're going to focus on the user-defined ones now. When you're writing a function in C, there's a certain way to set it up. First, you decide on the return type. This is the type of data the function will send back once it's done. It could be an int, float, double, char, or even void if it doesn't return anything. Next up is the function name. This is like a label for your function, and it follows the same naming rules as other identifiers in C. Start with a letter, and then you can use more letters, digits, or underscores. Now, for the parameters, these are the inputs your function needs to do its job. You list them inside parentheses. If your function doesn't need any inputs, just use empty parentheses. Each parameter has a data type and a name, and if you've got multiple, separate them with commas. Then there's the function body wrapped in curly braces. This is where the magic happens. It's a block of code that actually does the work of the function. You can declare variables, use statements, control flows like if or while loops, and other C language stuff here. Finally, if your function is supposed to return a value, don't forget the return statement at the end. It sends the result back to wherever the function was called from. The value you return should match the function's return type, and that's pretty much it for user-defined functions in C. Alright, let's break down this C program. It's a pretty straightforward piece of code that demonstrates how to use functions. 1. First off, at the top, we include the standard input-output library stdio, so we can use functions like printf. 2. Then there's a declaration of a function named add. This is like giving a heads up to the compiler that there's a function called add, which takes two integers as inputs and returns an integer. 3. Next, we dive into the main function, which is where the program starts its execution. Inside main, there's a call to our add function with the numbers 3 and 4 as arguments. The add function does its job, adds these numbers, and returns the result, which we store in a variable named result. We then print this result to the screen with a friendly message. 4. Finally, after the main function, we have the definition of the add function. This is where we tell the computer exactly what add is supposed to do. In this case, simply take two numbers, a and b, add them together and return the sum. So essentially, this program is a neat example of how to define and use a simple function in C to add two numbers. A function declaration and a function definition serve different purposes, and they occur at different points in the program. A function declaration is a statement that informs the compiler about the existence and signature of a function, while a function definition provides the actual implementation of the function, including the code that is executed when the function is called. Here is a code challenge for you to get more practice. Calculate BMI function. Alright, so when we're talking about local variables in C programming, it's like having something in a specific room of your house. These local variables are declared inside a particular block of code, maybe inside a function. And just like the stuff in your room, you can only use these variables within that specific block or room. They're not visible or accessible outside of it. Now, once you're done with that block of code, like when you leave a room, those local variables are like things you leave behind. they're destroyed and you can't get their values back. Another thing to remember is that when you first create a local variable, it's like picking up a blank notebook. It doesn't have anything in it yet. This means their initial value isn't set, so you should always give them a value before you try to use them. Just like you'd write something on the first page of your notebook before you read it. This way, your program knows exactly what it's dealing with from the start. Alright, let's break down this C program. It's all about adding up numbers from 0 to a number you choose. 1. First off, it includes the standard I/O library because it needs to interact with the user. 2. There's a function named SumUpToNowns that's declared at the start, but it's defined later on in the code. This function is the real worker here. It adds up all the numbers from 0 to whatever number you give it. 3. Now, in the main function, it first asks you to enter a number. Once you input your number, it uses the SumUpToNow function to calculate the total sum from 0 to that number. This is done in the SumUpToNow function using a loop which keeps adding numbers to a sum variable until it reaches your number. 4. After the calculation, the program shows you the result, like if you entered 5, it would give you the sum of 0, 1, 2, 3, 4, and 5, which is 15. 5. Alright, let me explain the SumUpToNow function from the C program. It's a pretty neat little function that calculates the sum of all integers from 0 up to the number you give it. So, say you pass the number 5 to it, it's going to add up 0, 1, 2, 3, 4, and 5. How does it do that? Inside the function, it starts with a sum set to 0. Then, it uses a for loop to go through each number from 0 up to the number you gave it, adding each of these numbers to the sum. It keeps doing this until it reaches your number. Once it's done adding them all up, it returns the total sum. So if you're curious about the total of the first few numbers up to any number, this function has got you covered. Alright, let's break down SumUpToNow function in a laid-back way. Imagine you've got a number, let's call it n. This function is like your buddy who's super good at quick math. It takes your number n and says, hey, I'll find the total sum of all numbers from 0 up to this number for you. First, it sets up a little counter, sum, starting at 0. Then it kicks off this for loop starting from 0 and going all the way up to your number n. In each loop, it's like it's tossing each number into a growing pile. That's your sum getting bigger with each round. So, if you toss the number 5 at it, it's like adding 0, then 1, then 2, 3, 4, and then 5. It keeps a tally, and once it hits your number, it's done. It's like, cool, here's the total sum of all those numbers, and that's what it sends back to you, the sum of all numbers from 0 to n. Pretty handy, right? Just a simple function doing the math, so you don't have to. Let's talk about void functions in C programming in a more chill way. Think of a void function like a helper who does a job but doesn't need to report back to you. In C, when you create a function that doesn't need to give anything back after it's done, you call it a void function. It's like saying, hey, go do this thing, but you don't need anything in return. The way you let the program know that a function is a void type is by using the word void when you declare it. This is like telling the function you won't be returning any value. Void functions are pretty handy when you want to do something like make a message appear on the screen, but you don't need any information back from the function. Let's take a look at a simple example. Suppose we have a function named greet. This function is a void function because it's not going to return any value. Its only job is to say hello world on the screen. So when you call this function in your code with something like greet, it just does its thing, displays the greeting, and that's it. No need to give anything back, just a straightforward hello world and done. It's like a friendly wave. It does the job of greeting and nothing else is needed. Here is a code challenge for you to get more practice. Maximum of 3 numbers finder.